Somewhere in the highlands of the Philippines, a farmer walks through rows of banana trees that have already given up their fruit. To most people, this tree is done. Its job is finished. In a few days, workers will cut it down anyway, because a banana plant only fruits once in its lifetime. What happens next used to be simple. The stalk was chopped up and left to rot in the field, or burned. Millions of tons of it, every single year, are treated as nothing more than agricultural leftovers. But someone, at some point, looked at that thick, fibrous trunk and asked a different question. What if this wasn't wasted at all? What if it was raw material for something nobody would ever expect? If you love uncovering the hidden engineering behind things you'd never think twice about, this is exactly the kind of story worth subscribing for. Because what happens to this discarded plant stem over the next several days is genuinely one of the strangest transformations in modern manufacturing. The part of the tree we actually want isn't the fruit-bearing stalk itself, but what's called the pseudo-stem, the tightly wrapped layers of leaf sheaths that make up the trunk. Slice through one and you'll see it's not solid wood at all. It's more like a thick, wet bundle of nested tubes, layer after layer wrapped around a soft core, each layer packed with long, straight fibers, running the entire length of the plant. That fiber is the entire reason this process exists. Harvesting these massive trunks is a brutal and physically demanding task that must happen quickly after the fruit is picked. Because the pseudostem is mostly water, a single freshly cut trunk can easily weigh over 50 kilograms, requiring workers to maneuver them by hand through muddy and dense plantation terrain. Time is of the essence here. If the harvested stalks sit too long in the humid tropical heat, the moisture inside begins to ferment, spoiling the fibers and rendering them completely useless for high-grade textiles. Only the healthiest outer layers are selected for this lucrative premium fiber processing line. Workers begin by cutting the pseudostem into manageable sections, usually a meter or two long, and splitting them into individual sheaths. Each sheath gets fed into a machine called a decorticator, and this is where the real transformation starts. Inside, a rotating drum studded with blunt blades scrapes and crushes the sheath against a fixed bed, repeatedly, aggressively, breaking apart the soft, pulpy tissue while leaving the tougher fiber strands intact. It sounds almost too rough a treatment for something that will eventually be marketed as silky and delicate. But this brute mechanical force is essential. Without it, you're just left with wet plant mush. What comes out the other end is a wet, stringy tangle of raw fiber, still coated in plant sap and cellulose residue, still smelling distinctly of banana. At this stage, it looks nothing like anything you'd want near your head. It's coarse, greenish-brown, and clumped together in uneven strands. This is where the labor becomes intensely hands-on. Workers pull the fiber apart by hand, separating strand from strand, checking for consistency and thickness, discarding anything too short or too damaged by the decorticating machine. Washing comes next, and it isn't a single rinse. The fiber goes through repeated washing cycles in large tanks, sometimes with mild natural cleansing agents, to strip away the residual plant sap, chlorophyll, and any lingering organic debris that could cause the fiber to rot or attract mold later. Banana fiber is naturally hygroscopic, meaning it holds onto moisture aggressively. So getting this washing stage right determines whether the final product lasts or falls apart within months. Once washed, the fiber moves outside or into large drying facilities and gets laid out in the sun. This isn't a fast process. Depending on humidity and thickness, sun drying can take anywhere from a full day to several, with workers turning the strands periodically to ensure even drying and to prevent uneven stiffness from forming in the fiber. You'll notice the color shift as it dries, moving from a dull greenish tone toward a warmer, straw-like golden brown, sometimes even a deep amber, depending on the specific banana variety used. Dry fiber is brittle and tangled, so the next stage is combing, or what's traditionally called hackling. Workers draw the fiber strands through a bed of metal pins, sometimes multiple beds with progressively finer spacing, which does two things simultaneously. It aligns every strand so they're running parallel to each other instead of tangled, and it separates the coarser outer fibers from the finer inner fibers, which will eventually be sorted into different product grades. The coarsest fibers might end up in ropes, mats, or heavy-duty textiles. The rise of plant-based hair alternatives addresses a massive and growing dilemma in the modern beauty industry. Synthetic hair extensions, while incredibly cheap, are fundamentally made of plastics like polyester and acrylic, which shed harmful microplastics and refuse to biodegrade. Meanwhile, the ethical supply of natural human hair is increasingly volatile and expensive. Banana fiber offers a brilliant middle ground because it is entirely biodegradable, cruelty-free, and has a natural light reflecting quality that mimics human hair far better than plastic ever could. For eco-conscious luxury brands, this byproduct has quickly become the ultimate sustainable holy grail. This is where the fiber's second life truly begins to take shape. To turn banana fiber into something that can pass as a hair extension, it needs to go through chemical softening. Raw banana fiber, even after washing and combing, is still fundamentally stiff, made largely of cellulose, hemicellulose, and lignin, the same structural compounds that give the plant its rigidity in nature. Softening baths, typically using controlled low-concentration alkaline treatments, work to gently break down some of that lignin structure without destroying the fiber's underlying strength. It's a careful balance. Too weak a treatment, and the fiber stays coarse and unusable. Too aggressive, and you dissolve the very strands you're trying to preserve. After softening, the fiber often goes through a dyeing process. Since natural banana fiber in its dried state carries a limited range of earthy tones, and commercial extensions need to match a wide spectrum of natural human hair colors, from jet black to auburn to platinum blonde. Dye baths are heated, and the fiber is submerged for controlled periods, with technicians checking color uptake and consistency along batches to make sure every strand within a bundle matches. Once dyed and dried again, the fiber reaches what might be the most delicate stage of the entire process: individual strand sorting and alignment for extension-grade products. Workers, often with years of specialized experience, separate fiber by length, by thickness, and by how well it catches and reflects light, since this determines how convincingly it will mimic real human hair once installed. Bundles are tied at one end, keratin-style bonds or wefts are attached depending on the intended final product, whether that's clip-in extensions, tape-ins, hair pieces sewn into a track. Quality control here is unforgiving. A single strand that's inconsistent in thickness compared to its neighbors will show under bright light. Fiber that wasn't dried evenly will hold moisture differently and create a subtly different texture that experienced buyers can feel between their fingers within seconds. So every finished bundle gets inspected, sometimes multiple times, before it's approved for packaging. What's remarkable is that this same raw banana fiber, at earlier stages of coarseness, branches off into an entirely different set of products. The stiffer strands become rope and twine, strong enough for agricultural and industrial use. Woven together at different densities, they become placemats, baskets, and structural textiles. Pulled down further with water and mechanical beating, the fiber transforms again into banana paper, prized for its texture and durability, often used in high-end stationery and packaging. Consider what actually happened here. A plant that fruits exactly once, then gets cut down and typically discarded as agricultural residue, has been split into a dozen different supply chains, all because someone bothered to ask what its fiber could become instead of asking what to do with the leftovers. Millions of banana pseudo-stems are still burned or left to decompose in fields worldwide every year, an enormous volume of usable material simply going unclaimed. So here's the question worth sitting with. As more industries start looking at agricultural byproducts as raw material instead of waste, What other everyday crops might be hiding a second, completely unexpected life inside them? Let us know what you think it might be down in the comments, and if this kind of hidden industrial process fascinates you as much as it fascinates us, stick around and subscribe because we've got 4 more of these transformations coming.